Initially, the capacitor is charged. Click the switch and observe the V-T graph, Q-T graph, and I-T graph for the discharging process. The charge, current, and voltage decrease exponentially with time. After a time t, when the switch is closed, the current in the circuit is I and the charge on the capacitor is Q. The potential drop across the resistor, IR, equals the potential difference across the capacitor, Q over C. Click on the step boxes to view the derivation of Q as a function t. Now click the graph button. A graph of charge Q of the capacitor against time t is shown. It shows that Q decreases exponentially with t. At t equals RC, the charge will decrease to 1 over E, or 37% of the initial value. RC is known as time constant tau. Click the next button to derive the expression for current as function of time. Click on the step boxes to view each stage of the derivation. Click the graph button to display the graph of I against t. The variation of current I with time t during this charging process is as shown in the graph above. The current decreases exponentially. What is the current I at t equals 0? T equals RC. Click the answer button. Click the next button to derive the expression for voltage across the capacitor during this charging process. Click on each of the text box sequentially to derive the expression for voltage across the capacitor during the discharge process. Now click the graph button to display of V against T. Graph of potential difference V across the capacitor with time t shows that V decreases exponentially with time. Summary. There are two types of lightning discharge. Cloud-to-cloud lightning occurs between the opposite charges in a cloud and are about 3 times more numerous than cloud-to-ground discharges. Cloud-to-ground lightning occurs between the portion of the charged surface of the cloud and the ground. The charge on the lower surface of the cloud induces opposite charge to be built up in the ground below. This is similar to charge induced on capacitor plates. The air between the clouds and ground becomes the dielectric of this natural capacitor. Eventually, the potential difference between the clouds and the ground becomes so great that the air begins to ionize. The ions and free electrons provide the necessary path that short-circuits this natural capacitor, initiating a flash of lightning. Summary. There are two types of lightning discharge. Cloud-to-cloud lightning occurs between the opposite charges in the cloud. Cloud-to-ground lightning occurs between the charged surface of the cloud and the ground.